Okay, let's dive into the sources today on something really critical. There's urgent news concerning African swine fever. Taiwan's managed this incredible 7-year guard against it. But that defense might now be broken. And the potential source, possibly linked to a recombinant virus strain from Vietnam.
Yeah, it's worrying news. And it forces us back to a conversation that, well, experts like Professor Lin have been highlighting for years. So for this deep dive, our mission is really to tackle a major biomedical myth. It's this assumption that, there's a workable ASF vaccine out there.
Right.
The hard truth, the brutal truth, is that even today, the world just doesn't have a truly good, reliable vaccine against African swine fever.
And it's not just about the virus spreading, is it? The sources are really clear there's a danger in the panic. This idea that the industry, feeling desperate, might rush towards using vaccines that aren't proven or worse, are unstable.
Exactly. And that could actually be a much bigger risk than the outbreak itself.
Okay, so let's break it down. Why? Why is the specific vaccine proving so incredibly difficult to develop? What are the main roadblocks?
Well, the scientific community generally points to two fundamental problems, really big ones. First, the type of virus you need. We know that inactivated virus, basically a dead virus, it just doesn't work. It fails to trigger an effective immune response for ASF.
So you can't use the standard dead virus approach.
No. You absolutely need to use a live virus or one that's been significantly attenuated, meaning weakened. That's hurdle number one.
Okay, a live or weakened virus.
Yeah.
But then there's the second issue, which sounds like the real kicker.
That's the lack of cross-protection. It's a huge challenge,
To me.
meaning immunity is incredibly strain-specific. So let's say you develop a vaccine that protects a pig against virus strain A.
Right.
That protection is pretty much useless if the pig then encounters strain B or C or D.
Oh,
It only works against the homologous strain, the one it was made from, or one extremely similar.
I see. And this virus isn't exactly simple, is it? There are many strains.
Oh, it's incredibly diverse. We currently recognize something like 23 different genotypes and 8 serotypes globally. Massive genetic variation. So finding one vaccine to cover all that, it's almost impossible right now. Think about the strain spreading in China, genotype 2, serotype 8. A vaccine for a different type just won't cut it.
That variability, that lack of broad protection, it leads us to a really stark historical warning, doesn't it, from the 1960s?
Yes, a very serious one. There was an outbreak in Portugal and Spain. Researchers at the time went ahead with an attenuated, a weakened live virus vaccine. They inoculated about 500,000 pigs.
500,000. And the result?
It was a catastrophe. Instead of getting immunity, these pigs became asymptomatic carriers.
Asymptomatic. So they looked healthy.
Perfectly healthy. They weren't cold, obviously.
Right.
And they acted as silent super spreaders, just walking around, shedding virus completely undetected.
How long?
For nearly 40 years. This actually worsened the epidemic across Europe, arguably until about 1999. It's a chilling example of using unstable or unsafe vaccines.
40 years. 500,000 pigs acting like biological Trojan horses. It's sobering. Okay, so that's the historical nightmare scenario. Fast forward to today. We saw Vietnam make a big push recently. Their vaccine, Navit-Acefak, got approved in May 2022, hailed as the world's first.
That's right. And initially, the reports were very positive. Protection rates claimed to be above 90%. Huge celebration.
But it didn't last long.
Not at all. Just 3 months later, it was suspended. Why? Because dozens of pigs that had received the vaccine died.
Okay, so what was the official explanation? The sources mentioned blaming improper handling or dosage issues?
Yeah, that was the initial line from officials. Kind of a standard response when things go sideways. But the scientific community, they were skeptical from the start.
And was that skepticism justified?
Absolutely. It was validated quite strongly by a study published just this past March 2024. The findings were pretty damning. It concluded that the vaccine strain they used, this ASFEG 177L, was genetically unstable.
Unstable how?
Critically, the study found it reverts to virulence, meaning the weakened virus could become dangerous again. It also negatively affected pig reproduction. The conclusion was blunt. It's an unsafe vaccine strain.
So basically the science confirmed the long-held fears.
Pretty much. It really underscores what many experts, like Professor Lin, have been saying all along. The challenge isn't just about getting a vaccine quickly, it's about getting a safe one. And we're just not there yet.
Right. So for you listening, what does this all boil down to? It seems the hard reality is that a quick fix isn't available. Safety is paramount, and the world hasn't cracked that code for ASF.
Exactly. Which means, for now, the only truly effective tools we have are, well, quite practical and unfortunately drastic. First, rapid culling and strict containment measures in countries where it's already broken out. And second, for places like Taiwan, it means doubling down on epidemic prevention, border controls, just really strengthening those defenses.
It's a sobering reminder of how complex these biological challenges are. This virus, ASF, it's massive. Sources say it has over 70 proteins just dedicated to suppressing the host's immune system.
It's a formidable opponent.
It really is, and it makes you think, given that complexity, are there other areas in biomedical research where maybe we're underestimating the sheer time, the deep critical thinking required before we can truly claim success? Something to mull over after this deep dive.